Okay, this is May 2015, paper 1, time zone 2, question number 8, first section B question on this paper, and it's all about quadratics. So, we've got f of x is equal to this function here, and we've got a diagram that shows us what the curve of that looks like. And part A says write down the value of P and Q. The instruction write down is telling you that you don't need to do any calculations. You should, if you understand the question, just be able to give the answer straight away. The reason for that is P and Q are the two roots. They're the places where the function f of x is equal to 0. If f of x is equal to 0, then that must mean that one of these two brackets is 0. Either x plus 3 is 0, or x minus 1 is 0. That's the only way that function will be 0. That's sort of a fundamental understanding of quadratics, which means our answers are that p is equal to, what value of x will make that 0? Well, p will be equal to negative 3. And what value of x will make that 0? It's q is equal to 1. Make sure you get these the right way round. The numbers minus 3 and 1, because p is obviously smaller than q. P is the negative one. If you look at where it is on the diagram, q is the positive one. Okay, and part 2 of this question, find the value of a. Well, there's a little bit more work to do now, but there's one piece of information that we haven't used, which is this point here, which is the coordinate 0, 12. So for part 2, I'm going to start off with f of x is equal to a times x plus 3, x minus 1, and I'm going to evaluate that at f of 0, which will be a times 0 plus 3 times 0 minus 1, and that's got to be equal to 12 from this coordinate here. This is fairly easy to evaluate. 0 plus 3 is 3, 0 minus 1 is minus 1, so that becomes a times 3 times negative 1 equals 12. Minus 3a is 12, so a is equal to negative 4. And you should expect a to be negative because the curve is going as a frowny face, so that's a negative coefficient. If a was positive, it would be curving the other way. Part B, find the equation of the axis of symmetry of the graph of f. Axis of symmetry down here, which is in the middle of P and Q. And we just worked out P and Q on the last slide, minus 3 and 1. There's loads of ways to figure out what number that is that's in the middle there. The easiest is to take the average of minus 3 and 1, add them together, divide by 2, and you get negative 1. So that's this value here. Make sure you do what the question says and find the equation. The equation here is x equals negative 1. Part C, I'm going to see if I can squeeze on the same slide because it follows on directly. Find the largest value of f. Well, the largest value of f is up here at the top, and we've just worked out the x coordinate of that is minus 1. And the question is, what's the y coordinate? How high is the graph at that point? Well, we know that f of x is equal to -4, that was in part A, x plus 3 times x minus 1. So essentially all we have to do is evaluate f at -1, which is -4 times -1 plus 3, -1, -1, which is -4 times 2 times -2, which is -8 plus 16. So that's this coordinate here, -116. That's the largest value of f. Part D, the function can also be written as f of x is equal to a times x minus h squared plus k. Find the value of h and the value of k. You'll notice they've used the letter a again. Now, you might not have this level of rigor when you're answering the questions, although you should. But if they've used a twice, then that's sort of telling you that that's the same a. Now, there's a couple of ways to do this. Your instincts might be to take this, expand it, and then turn it back into completed square form. And that will work, but it'll be long-winded. And there's a lot of opportunities to make an error if you go about it that way. Remember, section B questions are generally structured so that they build on each other. And we've seen how we used the answer to part A, the values of P and Q, to find the axis of symmetry. We've seen how we use the value of A to find the large and the axis of symmetry to find the largest value of f. Now that we've done all that, it all ties together in part D when they're asking us to complete the square, because it really relies on our answer to part C, which was -116. Because you should know that the completed square form, f of x is equal to a times x minus h squared plus k. Well, we get the turning points, the maxima or the minima, when x minus h is 0. So we get, in this case, it's a maximum. We get our maximum when x minus h is 0. Because the biggest value of x minus h squared, remembering that a is negative. This is negative. So the smallest value of x minus h squared is when x minus h is 0, because anything else that's been squared is going to be positive. If x minus h was a negative number, when you squared it, it would be positive. If x minus h was a positive number, when you squared it, would be positive. So we have x minus h is 0 is the smallest value when you square it. And because a is negative, and because this curve goes the other way, and that ends up corresponding to a maximum point. So we've got our maximum at x minus h equals 0. But we also know we have our maximum at x is -1 from over here. There's our maximum. So therefore, x, nope, not x, -1 minus h must be 0, which means h must equal -1 as well. And when we have that maximum, when x minus h is equal to 0, this part of the completed square will all vanish. Which means that k must be equal to our value of y. So k is equal to to 16. And we're done. Although the completist in me wants to write out f of x is equal to minus 4 times x plus 1 squared plus 16. And that's the function written in completed square form.